All right, welcome to the last video on probability. This involves the last two sections, which is conditional probability. So what we're talking about is the probability that one event occurred, given that a second event that it is dependent upon occurred. All right, it's called conditional probability. If they give you a table, my suggestion to you is cross out what doesn't apply. And we're going to walk through this in a second. All right. If a formula is necessary, so they just give you information, we're going to try to do things. Probability that B given A, okay, so the probability that B occurs, given that A occurs, is the probability of both A and B happening divided by the probability of A. A is guaranteed to happen, so whatever that probability becomes 100. So basically what we're doing is we're shrinking the sample space. Now, if you look at 13.5 standardized test prep attached handout, you'll see, okay, a table. Okay, so we're going to walk through the table with each of these. All right, so number one, it says, what is the probability that a randomly chosen person ran and wore a blue t-shirt? The key word there is and. All right, so this isn't dependent upon the other. They both had to happen. So basically, when we look at the table, we're looking for the people that ran, which is this row, and then wore a blue t-shirt, which is this column. How many people did that? 20. All right, so that would be 20 out of 160. And 20 out of 160, if we put in a calculator, is 0.125, which is A. So our answer would be A. If we look at number two, it's again an and problem. What is the probability that a randomly chosen person walked and wore a red t-shirt? So now we're looking at this row, which is walked, and wore a red t-shirt, which is this column. All right, so that would be 30. All right, so now we're looking for 30 out of 160. And when we go to our calculator, 30 divided by 160 gives us 0.1875. So the answer to that one is G, as in glistening. All right, now 3 and 4 are the conditional ones. It says 3, what is the probability that the person ran given that they wore a blue t-shirt? Whatever comes second is guaranteed to happen. So we're saying that everybody we're talking about here wore a blue t-shirt. So we're no longer interested in that column. We're no longer interested in that column. We're simply looking at the first column. All right. How many of those people ran? 20. How many people total were there? 100. 20 divided by 100 is 0.2. All right. So that's going to be A once again, as in apple. All right. And then finally, number 4, what is the probability that a randomly chosen runner wore a blue t-shirt? Okay. So now we're only talking about the runners. All right, so now we can get rid of the walkers, we can get rid of the totals, and we're only focusing on this row, and all the columns now are in play. All right, so the blue t-shirt is 20. How many people total were there? 50. So we would do 20 divided by 50, which is 0.4, and 0.4 seems to match up with letter G. All right, so we got a gag. Get it? A gag? All right, so number 5, when calculating probability of B given A, why is probability A in the denominator? Because the A becomes 100%. We're making the sample events, or the total possible outcomes, guaranteed to be that. Now, when there's not a table, okay, in the notes you'll see we use a tree diagram. I think this is going to be helpful. A second thing that can be helpful for a lot of you, and this is a test-taking strategy, is it says, all right, there we go. A physician determined that on average 40% of his patients got the flu each year. Of this group, 10% received the flu vaccine. Of the patients who do not get the flu, 20% received the flu vaccine. Use this information for exercises 1 through 2. Since we're dealing with percent, and you're allowed to do this, this is huge on college placement tests, on SATs, ACTs. Whenever we're dealing with percent, we can use whatever number we want. Now, in this case, I used 100 patients. Why? Because that's the easiest to calculate a percent of. So we're going to say, instead of all his patients, we're going to say 100 patients. That way, when they say 40% of his patients got the flu each year, well, that means 40 got the flu. Well, if we do 100 minus 40, that means 60 of his patients did not get the flu. So now we read more information. It says, of this group, so now we're focusing on this group, the ones that got the flu, 10% received the vaccine. So I do 10% of 40, which is 4. So 4 are vaccinated. 40 minus 4 is 36 did not receive a vaccine. Okay, if it comes out to a decimal, it's okay. All right, now we then go to the other group. It says of the patients who did not get the flu, 20% received the flu vaccine. So now we're going to do 20% of 60. So we're going to do 60 times 0.2, which is 12. So that means 12 received the vaccine. 60 minus 12 is 48. So 48 did not receive the vaccine. So now instead of dealing with percentages, now we got numbers. If you want to put in a table, fine. It's not necessary if you just want to use the tree diagram. Number 1 says, what is the probability that someone who did not receive the vaccine got the flu? So we're only talking about people who did not receive the vaccine. So 36 here didn't get the vaccine, 48 there did not get the vaccine. We add those together, that's our bottom number, 84. All right, 36 divided by 48. 36 plus 48 is 84. All right, it says got the flu. Well, how many of those people got the actual flu, all right, that did not receive the vaccine? All right. All right. Probability that someone who did not receive the vaccine got the flu. All right. So that means 84 did not receive the vaccine. How many that did not receive the vaccine? Oh, so it's 36. All right. So it says, what is the probability that the people who did not receive the vaccine got the flu? How many of these people did not get the flu? Those 48 did not. Those 36 did. So it's 36 out of 84. 36 out of 84, when I'm done reducing, comes down to 3/7. And 3/7 when I compare it to the decimals is B, 0.43. Second one, what is the probability that someone who received the vaccine got the flu? So how many people received the vaccine? 4 here, 12 there. 4 plus 12 is 16. So 16 people received the vaccine. How many of those people got the flu? Well, that's 4. And hopefully by now, dealing with all these, 4 out of 16, you realize is 1/4. And 1/4 is 0.25. So letter F is our answer to that one. All right, 2 more. All right, 2 more. Again, it says of the 85% of the students in the class who studied for a test, 75% passed the test. Of the 15% of the students who did not study, 30% passed. What is the combined probability of passing? So I'm going to go back to 100. It says 85% of those studied. Well, this is why we use 100. That means 85 studied, 15 did not. It said of those that studied, 75% passed. So we would do 85 times 0.75. That gives us 63.75. Don't worry that it's a decimal. We're dealing with theoretical. 85 minus 63.75 is 21.25. That means, unfortunately, 21.25 of the people, theoretically, who studied did not pass. Now we're going to look at the other group. 85 studied, 15 did not. 100 minus 85 is 15. It said of that group, 30% passed. So 30% times 15 would be 4.5. Okay? And then subtract 15 minus 4.5, we get 10.5. Again, decimals are fine. It's theoretical. Message of the story, by the way, if you look at it, study. All right, so now it says, what is the combined probability of passing? 63.75. Again, this is out of 100. That makes our life easier because that means we can automatically just turn that to a percent by adding the percent symbol. All right, and then passing, 4.5 over there, so we can turn that into 4.5, and then all we got to do is add. 63.75 plus 4.5 is 68.25, and as a decimal, that is going to give us C as in clue. All right, so basically that's how we do that. Now, number 4, we'll give you an example of doing it with the formula. All right, in a survey, 60% of the people own a laptop computer. 80% own a desktop computer and 30% own both. Okay, the reason I'm using the formula is there's an overlap. It says, what is the conditional probability that a laptop computer also owns a desktop computer? Okay, so whatever comes first goes on the bottom. That's why L is on the bottom, a laptop. All right, because they say, what is the conditional probability that a laptop computer also owns a desktop? So now the probability of a desktop is they have both. The formula we give you, the probability of a desktop, given that they have a laptop, is the probability of both. There's our and over the probability of L. It says 60% own a laptop. So that's why my denominator is 0.6. 80% own a desktop. That's great, but we're not going to work on that because we're going to focus on this, the 30% that own both, because that's going to be our numerator. All right. Our numerator is 0.3, denominator is 0.6. 0.3 over 0.6 gives us 1/2, and 1/2, as we all know, is 0.5. All right, I hope it helped. Good luck with the rest of the packet. Remember, if you want to do nothing over the weekend, it is all due on Thursday. Seems like a lot, but it's a lot of fractions and you're filling in. All right, if not, make sure you finish it over the weekend. Monday, we will post. All right, and that's through Monday. And then Tuesday, we will post the probability quiz, and you'll have 2 days to complete that bad boy. Best of luck. See ya.